Adilah, kenapa kerusi kat atas tu? Si Nur Adilah ni buat the je. Kerusi atas katil. Oh, Okay guys, welcome back. Ya Adilah, kenapa engkau bertanduk? Okay. Guys, welcome back to this plant operation and management class. So we will continue for another sub-session, which basically we need to cover by today. By the way, tomorrow we are not having class, right? You know that you are having your final year project briefing. Betul kan? Okay, so rasanya for this month itu saja basically yang you all ada briefing yang yang menyebabkan keluar kita cancel. But don't worry, after this we don't have the class, and we need to cover these 2 days, which basically about 6 hours. So we need to cover some days, some way in the next month before Dr. Aziz take over the class. Okay, so okay, so let's take a look at this. Hari itu kita dah sampai ke plant operation and plant design and operation revisited part 1. Okay, so let's take a look back on this plant design and operation, especially on the reactor. Kita tengok balik. Okay, ramai juga yang masih lagi tak beberapa penamaan. This is just about the naming. How that you differentiate between the unit operation with another unit operation. Ada lagi yang nak masuk? Alamak, ramai lagi nak masuk ni. Tak apa. So we start with this page stirred tank reactor. Okay. Okay, untuk yang ini, you all boleh on mic kalau saya tanya, kalau nak menjawab soalan. Okay, sama juga dengan the next part 2 and part 3. Since most of you already answer it there in open learning, so I think it's better kalau kita boleh communicate verbally pula. Right? So this is what, guys? What kind of reactor this? You call this? Don't have any input stream and you don't have any output stream. So if you don't have any input and output stream, we call it a batch reactor. But remember that here we have stirrer. So don't forget about the stirrer. Most of you basically forget about the stirrer. So this is, we call it stirred tank reactor. Oh, sorry, stirred tank batch reactor. Okay, stirred reactor, stirred tank reactor batch or whatever, it should be about stirrer and also a batch. Okay, so most of you got correct of that of this. So when you are having one single feed in, so you can, there is two names of this. Commonly we call it feed batch. Okay, and another which is really common, this also we call it semi-batch stirred tank reactor, because we only have one single feed stream, so it's called semi-batch. But commonly, since it is only have a feed stream, so usually commonly in industry people call it feed batch. Okay, all right. Qayyum, serius sangat tu Qayyum. Tentang tepi pantai. Then we have another one here. Okay, most of you answer it as a feed batch, starting reactor. All right, so this one, okay, quite easy. We call it semi-batch because you only have one strip out. So it's a semi-batch, starting reactor, okay, good. And all right, yang ini, most of you got it right. STR is quite common, especially for the biochemical, for the bioprocess, quite common. All right, so one thing about a stirred tank reactor is basically used for a liquid phase reaction. Commonly used for liquid phase reaction. Okay. Kalau ada pun yang melibatkan gas phase, then you need to have some, at least you may have something that you may release the pressure, the gas at the top, at the safety valve or pressure release valve or whatever, because you cannot recover something as a gas at the top because we don't have the feed which is located at the gas phase, since we are put that stream at the bottom. So it is impossible for you to recover gas at the bottom. Okay, so you put some venting instrumentation there. Okay, that's for the safety reason. Okay, nanti bila kita masuk pada part heads up or safety, then you need to put some of the instrumentation there in order for you to maintain the pressure. Okay. Okay, we have about 58%. All right, that's good. All right, so we go next. Ini ke? Saya dah lagi ke? Oh, okay, this is the difference between, then we have the difference between the constant level atau fixed level CSTR. In this case, that you know that some of the advantage and also the disadvantage of having a fixed level or not. So here we have at the left hand side, we call that is the non-constant level CSTR ataupun level varies level CSTR, and we have at the right hand side we call it the constant level CSTR. So the disadvantage for the level, for the constant level CSTR, that you don't need to have a control level. You don't have to have a level controller there because the level is always fixed. Okay, level is always fixed. And for the left hand side, the advantage there, if your production is ataupun you punya throughput, okay, varies, therefore you may use the left hand side. Kalau you punya production tu setiap tahun dia berubah, nak besar, kecil, whatever, then the left hand side CSTR is the best solution. Tapi kalau you punya production maintain, then you just use the one with the constant level. So that is one advantage and disadvantage. Apa yang you all tulis kat sini? Temperature can be controlled. Oh, Andrew dah keluar. Tadi dia nampak dah keluar ni. Andrew Raj. Kita tengok apa. Advantage of CSTR, controller can be controlled. Disadvantage, low conversion to unit volume. Disadvantage. Okay, for information, both kind of this CSTR basically you can control the temperature. Because tak ada kaitan pun dengan level temperature. Okay, both you can use to control temperature, tak ada masalah. Able to control temperature, sama je berarti. Low conversion temperature above flow can be avoided. Restricted level control. Ayat engkau tu pusing-pusing je, padahal sama je. Temperature can be controlled easily. Saya tengok orang lain yang awal-awal jawab macam mana. Okay, Noha. Able to maintain the temperature. Sama juga. Prevent the overflow. Okay. Mari kita tengok apa advantage and disadvantage of this. So both basically you can control temperature. Tak kisahlah kau punya level tu constant ke tak constant, but still level can be temperature can be controlled, because temperature is just you need to use put some jacket or put some pipe there, piping the coil inside the reactor, the vessel, and you may able to control the temperature. So both don't have any problem in controlling temperature. The only problem is when you want to control level. Okay, yang kiri, of course, you need to have level controller. You need to install level controller. Whereas at the right-hand side, tak perlu. Okay, so there is advantage and disadvantage there. Okay, and also regarding to this level controller, since you have a fixed volume for the right-hand side, therefore the production is fixed. Okay. The production is fixed, whereas at the left-hand side, you may change, you may able to optimize or varies your production. Sebab production or the conversion of the process of this reaction basically depend on the volume. Okay, conversion may be increased, can be increased or not, depending on the volume selection. Okay, depending on your volume selection. Tapi yang belah kanan tu, conversion is fixed since volume is fixed. Okay, unless that your reaction is as a function of temperature. Okay, if your reaction is as a function of temperature, either endothermic or exothermic, then the increasing ataupun the difference between the levels, okay, if your level is varies, then it will have some effect. It will affect the temperature or in the reactor. Okay, it may increase or decrease depending on the level, because when you have a more conversion, for example, if you're having exothermic reaction, more conversion means more heat will be released and your outlet temperature will be higher. So in order for you to maintain it, therefore you need to add more cooling water to reduce or to maintain the temperature. Okay, so on the other hand, if you are having endothermic reaction, so the variation in the level, in the volume, basically will also change the temperature. For example, if you have a more conversion, for an endothermic reaction, more conversion means more product will be produced, therefore more energy will be used, more heat will be used. Okay, therefore the temperature at the outlet stream will reduce. Therefore, you need to put more steam, for example, if you want to maintain the temperature. Okay, so that is the difference. There is the advantage and disadvantage. All right, so what you need to do for this, please comment. I will also comment on this. For example, the statement about advantage and disadvantage on that. Okay, so you can make some correction here. Low conversion per unit volume, I don't think that is the disadvantage of low conversion. Kita tengok yang paling awal. Ada lagi. Tengok Akmal. Can control volume of solution desired solution overflow of mixture cannot be controlled? Juga. Now, advantage and disadvantage is that nothing to do with this. For the constant level system, prevent from overflow is basically overflowing, but the volume is keep constant. Restriction for volume of solution. Restriction for volume of solution. Tapi I think most of you need to do some correction. Okay. Ya, minum dulu. Alright, so kita pergi ke session yang seterusnya. This is very interesting. I found that is a lot of different answer from all of you. And interestingly, none of them satisfy my expectation. Oh, maksudnya macam-macam lah jawapan korang ni. Okay, kita dah tengok reaction which is more on stirred-tank reactor. Now we look for separation system. Remember that in a chemical plant, the heart of the chemical plant is a reactor. If you want more output or productivity of your reactor, of your plant, so make sure that you're able to achieve the highest possible, not conversion, we are not talking about conversion here, we are talking about yield. Alright? Please, sepatutnya saya tanya soalan ni kan. What is the difference between conversion and yield? Apa? Let me explain. Okay, mungkin lepas ni saya tambah soalan ni, mana tahu dalam ni. Okay, please always check dalam ni. Sebab kadang-kadang saya tiba-tiba nak tanya soalan, saya boleh letak saja. Alright. Well, in this case, I just mentioned about the difference between the conversion and also the yield. Okay, it's different. But how you want to define this, basically you need to look at the reaction rate. Okay, when you need to look at a reaction rate. If you have a forward reaction, okay, if you have a forward reaction, A plus B becomes C plus D, for example, where C is your desired product and D is your side reactant, side product, then you need to have more C. In order for you to produce more product C, you need to have the highest conversion possible, right? But that is conversion, and also it also relates with the yield, the same. Because you want to have more yield of product C, you need to have the highest conversion of A and B to produce C. That's for the forward reaction. Okay, that's for the forward reaction. More conversion, more product C will be produced. Okay, will be produced. On the other hand, if you have a forward and consecutive reaction, you have a forward A plus B becomes C plus D, and you have another one C plus D become E plus F. Whereas your desired product has been used for another secondary reaction. You have a primary reaction, A plus B becomes C and D, and the secondary reaction you have a C plus D become E plus F. Your desired product has been used in the second reaction.
Aku tu buka tu. Tong.
Let me check.
Tong.
Tahu punya tu.
Tong.
Ada lagi ya? Semua dah off? Ada tong. Apa benda kau buat tu? Tengok movie dia tu. Kau jangan gelak, Is. Kau gelak kan ngantuk tu. Okay. So, if you have a consecutive forward and consecutive reaction or reversible reaction, then you may not able to produce more of your desired product when you have a more conversion. Because some of the reaction may use your desired product to produce another side product. So in this case, yield is most important than conversion. Okay, yield is most important. Tapi kalau just forward, kalau you not more product, therefore you need to have the highest conversion as possible. Okay, so that is the difference. So in order for you to analyze this, make sure that you know, analyze the reaction rate. Forward, kalau forward saja, alright, maximum conversion is possible. If there is a reversible or consecutive reaction, then you need to make sure that the yield is the highest one. Although mungkin conversion tak setinggi yang mana yang kita nak. Okay, that is one. So this is also related with the operation, remember, and also management. How you manage the operation? Kalau you tak faham fundamental. Kalau you tak faham the fundamental of the reactor, of the reaction. Okay, you nak banyakkan apa yield because you nak dapatkan besarkan you punya production. Tapi reaction yang involved dalam tu is a consecutive, reversible and consecutive reaction. So you cannot push the conversion into a maximum. You takkan dapat product, the highest product that you want. Okay, therefore this is very important. Okay, alright. I will try to design one problem related to this yield and conversion, such that you may, because that also relate with the operation at the end. Okay, so once we have come up with the reaction optimization or reactor optimization based on this reaction rate analysis, then baru kita fikir macam mana nak dapatkan pure component. Okay, first thing first, reaction. Carry the maximum desired product as possible. Gunalah whatever ilmu yang you dah belajar dalam reaction, chemical engineering reaction tu, to produce the highest or to yield the highest desired product as possible. Okay? And another important thing is separation. Tak guna kalau you dapat the highest production, the highest conversion, tapi you cannot obtain the highest purity as desired by the market. Certain product, they have a certain quality, they have certain grade that you as a producer need to satisfy. Okay? And this is represented by the quality, product quality, which is based on purity, which is based on composition, product composition. Okay, sometimes you need to produce a component with 99% purity. That's quite high. Okay, and you need to select the best separator that can able to achieve your objective. All right, so let's take a look at this separator system. So we start with the simplest separator for vapor-liquid equilibrium. All right, so this is for the case of VLE only, not liquid-liquid equilibrium, not vapor-vapor equilibrium. Also not capable for solid-liquid equilibrium or solid-vapor equilibrium. This is only applicable for vapor-liquid equilibrium system. So the simplest separator for VLE system, which is, we call it flash, as shown as here. Alamak, terlambat. Okay. Let me make it okay. So this is flash, a single stage, one stage of flash, or sometimes we call it vessel, sometimes we call it flash drum, okay, which separate between liquid at the bottom and vapor at the top. That is the function of a separator. You cannot have a separation if you have only a single phase. This is for VLE, only applicable for VLE. You all tak boleh akan ada separation kalau ada single phase. So make sure that there is a two phase occur there, VLE. There is a vapor occur there, and liquid also occur there in the system. Therefore, you may do some separation. And the degree of separation, itu kita kena analyze. Before you want to select the most suitable separator that's basically satisfied in terms of energy consumption, for example, or based on the purity, for example. So that is only a constraint. Tapi yang penting for the VLE system, make sure that you have a clear separation between liquid and vapor. Okay, so a single stage, this we call it flash. Okay, we call it flash. Next. Okay, yang ini you boleh baca. How does a flash separator work? The next separator, which is, we call it column. But the function is also still the same as a flash. The only difference is that separator, that column, this is a column, has several stages. Tadi flash kita cuma ada one single stage, but in this case we have several stages, tetapi fungsinya masih lagi sama, yang mana you will recover liquid at the bottom and the product gas as a vapor at the top. Is there any question? Ataupun you tertekan, ataupun tengah berborak tiba-tiba tertekan. Okay, if you have a question, you may just on your microphone and ask direct question, ataupun you boleh juga type soalan dalam chat sana. But don't worry, yang ini kita just do some discussion because most of you already answer this. Okay, tak nampak, saya kecilkan sikit. Okay, nice. So you recover vapor at the top and you recover liquid at the bottom, but you have several stages. So the question is, what is the name of the separator? Okay. Most of you, mari kita tengok, call it distillation column. Nasib baik tak ada yang tulis a multi-stage flash. Mana tahu ada yang jawab multi-stage flash. Semua menjawab sebagai distillation column. Okay, straight to the point, all of you are wrong. This is not distillation column. Of course, this is a column, but this is not a distillation column. Okay, kenapa? Oh, nanti kita tengok one by one. Okay, tolong jangan buat terkejut muka kau ini. Bukannya distillation column yang sampai terkejut, ataupun tak dengar, korek telinga pula. Okay guys, please take notes that this is not a distillation column. Okay, it's a column but not distillation column. This one, kalau tengok dalam buku teks, kita panggil dia sebagai absorber. Okay, betul kan? Panggil dia sebagai absorber, but commonly in practice, in industry, they call it splitter. Okay, sometimes they call it as a general separator, tapi kita panggil sebagai absorber, not absorption column. That's different. Okay, they call it absorber, not absorption column. Absorption column ni basically you use when you have a solvent. You have a solvent at the top and you have your gas feed at the bottom. You have a multi-feed. Tapi ni you only have one single feed. Okay, this we call it absorber. Yang mana mungkin yang masuk tu adalah single liquid, single gas ataupun multi-phase liquid and vapor. But once it go inside, when it go inside to the column, some of the condensable gas akan terkondens dalam bahasa Melayu apa? Bukan tersejat. Teruap. Forget. Okay. When that condensable vapor touch certain stage, every single stage they have some packing ataupun dia akan ada dia punya either you have a bubble cap or whatever there. So once they touch the packing, then that condensable gas dia akan menjadi liquid. Some of them akan menjadi liquid. So bila jadi liquid dia akan turun ke bawah. Sepanjang dia turun ke bawah tu mungkin dia akan touch dengan ataupun berlaga dengan another non-condensable gas. Lagi semakin beratlah dia jadi. Okay, that is how that it works. And be in mind that there is no additional utility here. You tak ada heating utility, you don't have a cooling utility. So this we call it absorber. Fungsi masih sama, recover gas at the top and recover liquid at the bottom, but you have a multiple stage. Alright, so this we call it absorber, not a distillation column. Remember, nama dia adalah absorber. Semua cakap distillation column. Ada yang lain ke? Tengok. Tak ada. Tak ada yang jawab selain daripada distillation column. Alright, tak apa. Okay, so we go to the next. So we have the same kind of separator macam tadi, which we call it apa kita panggil dia, absorber, right? So we call it absorber. But in this case, this kind of absorber, they have some additional utility, which we call it reboiler. We have a heating utility, which we call it reboiler. Bukan heater lah, sebab tugasnya adalah reboil. Okay, there is a recycling activity there, so we call it reboiler. Okay, so since you have a absorber and also you have a reboiler at the bottom, so what do you call of this kind of separator? Tengok apa jawapan yang you all bagi sini. Semi-batch reactive distillation column. Kat mana reactive areanya? Kat mana reactor dalam ni ada sampai you call it semi-batch? Kenapa semi-batch? Katakan this is continuous. You have a feed in, you have a two stream out. So you cannot call it semi-batch. Reactive, you don't have any reactive section there. Tak ada pun reactor dalam tu. Tak ada pun reaction section. Semua sama ni. Ini seorang jawab terus semua ikut. Alright. Kita tengoklah. Semua sama saja. So, guys, this is not reactive because you don't have this is the same absorber macam tadi. Yang mula-mula tu. The only thing additional here, you have a reboiler at the bottom. So, you have a column which you call it absorber and you have reboiler. So, bila dua ni you gabungkan, so what is the name? Anyone? You can switch on your mic. You have absorber. Apa sih?
Absorber with reboiler.
Oh, kau ni kena belajar bahasa Inggeris ni. Dalam bahasa Inggeris, kita tak boleh ada dua noun. One of them should become adjective. So siapa owner dia sekarang ni? Tuan dia adalah absorber. Sofi, tuan dia siapa?
Absorber.
Absorber. Jadi adjektif dia apa? Apa tambahan situ?
Absorbent.
Reboiler.
Reboiler is also a noun. Ya, Aiza.
Absorbent.
Not. Jadikan dia sebagai adjektif. Reboiler is a noun. Adalah nama. Sama dengan
Absorbent.
absorber. Absorber is a nama. So,
Absorbent.
since tuan dia adalah absorber, reboiler tu adalah tambahan.
Heating.
Heating. Jauhnya. Pakai tak? Reboiler tu jadikan adjektif.
Reboil apa?
Heated.
Apa nama dia? Reboil absorber.
Okay, thank you Zik. Yeah, Zuhairi Azman, thank you. That is the right term. Reboil, that become adjective. Tak boleh reboiler absorber. Dua-dua tu adalah noun. Salah. Okay?
Mantap jadi.
So, jawapan dia adalah reboil absorber. Sebab you ada reboiler.
Google.
Ha? Apa? Okay. Menarik kan? Lagi yang bawah-bawah ni lagi menarik. Adakah selama ni korang anggap semua tu adalah dissolution column? This is very important. You don't understand. Kalau you tak kenal, ingat guys, this is very important. You nak jadi plant manager, you kena kenal semua unit operation yang ada dalam plant. Okay? Kalau tak kenal, macam mana you nak operate? Ya.
Absorber or absorbing?
AB. Okay, Noha? Alright. So, yang pertama, kita tengok balik. Yang pertama tadi single stage, kita panggil dia flash. Yang kedua, ada kolom itu saja with the multi stage, we call it absorber. Yang ketiga, kita ada additional of utility, reboiler down there, and we call it reboil absorber. Okay, so jawapan semua ni tak boleh pakai. Okay. Cuma mana boleh pergi kepada reaktif, tak ada pun reaction section kat situ. Alright, so we go for the next type of separator. Dalam ini masih lagi kita guna tuan yang sama, iaitu si absorber. Okay, tuan yang sama. Kita guna si absorber tadi. Cuma ke atas tu kita ada tambahan utility. We have an additional utility, which we call it condenser. Of course, once you condense, you need to have a drum to separate between the liquid and also the gas. And it also depend on the total ataupun partial reboiler that you want to use. If you use a partial reboiler, then you may have a liquid and vapor as a product. If you have a total condenser, so totally you make the vapor all become a liquid. That's why we call it full ataupun total condenser. Okay, so dalam ni kita ada si tuan punya badan, which is absorber, dan tambah dengan condenser. So what do you call it? Okay, ada buat cek. Ya, Khairul Zakwan betul. Awal betul jawab. Okay, tak apalah, betul lah. Sebab condense. You are having condenser.
Baik,
And you use the tuan punya badan, which is absorber, then it's a condensed. Okay, condensed absorber. Is, kenapa tiba-tiba ada tangan tu? Tiba-tiba tepi apa, celah-celah air laut tu keluar tangan. Okay. So we call it condensed absorber. Okay. Persoalannya. Okay, we go for the next question. Bila masa kita boleh pakai, ingat as a manager, in the future, as a plant manager, you kena faham bila masa yang sesuai kita nak pakai semua ni. Okay, kita start dengan condensed absorber dulu. Bila masa kita pakai ataupun bila masa kita tak boleh pakai. Paling senang lah soalan dia, bila masa kita tak boleh guna condense absorber ni? Siapa boleh bagi opinion?
Apa tu soalan dia?
When that, bila masa, what the condition, what is your fit condition that not allowed you to use condense absorber? Aziz, kau dengan Qayyum sebelah-sebelah ke?
Saya punya internet slow sikit.
Kenapa seorang kat hotel, seorang kat pantai? Padahal duduk sebelah-sebelah je. Okay, soalannya. What kind of fit condition that not allowed you to use condense absorber? Condition apa dalam you punya fit stream yang tak membolehkan you all nak pakai condense absorber? Oh, ini open question.
Azeotropic condition.
Azeotrope, not really. Azeotrope masih boleh pakai. Sorry Zah, tambah lagi, boleh try lagi. That's a good try. Good try. Good try. One composition fit. No lah Sophie. You need to look at your fit condition. Apa yang ada dalam fit condition, dalam punya fit tu, yang kalau ada sahaja komponen tu, you all memang tak boleh pakai reboil absorber, condense absorber. But you can use reboil absorber. Any idea? Low boiling point tak ada. Low boiling point boleh sahaja, entahlah. Itulah kau, entahlah nak tak tahu apa. Impurities, not really. Gas, but gas should be some, orang panggil educated gas. Kita nak gas product, tak ada masalah. You can use this condense absorber, tak ada masalah. We are talking about the fit condition, not the product condition. Fit condition. Dalam fit tu, dalam ni, okay, apa condition yang ada dalam ni? Kalau benda tu ada, then you can use this.
A single component.
Ya, kalau you single component, buat apa you nak separate? It's already single mah. Alright, no need for you to separate if it is already single. More than 3 component, tak ada juga zip. Boleh juga. Look at the fit condition. Apa fit tu? Kalau ada saja komponen ni, yang ada dalam dunia fit, memang you tak boleh separate dia guna this condense absorber. Okay? Tak dengar siapa tu. Afika different boiling point batch. Azik, mana ada batch? Ini kan continuous, ada feed, ada outlet, ada out. Gas meruap, volatile, not really. If you have a volatile gas, masih boleh lagi.
Kalau boiling point yang terlalu dekat,
That's we call it
extraction.
yes, you can use extraction column, tapi extractive column, tapi yang ini masih lagi boleh. Irene solid, solid mana boleh guna VLE mah. Ini VLE. We're not talking about solid. We're talking about solid liquid vapor. Vapor liquid sahaja. Gas meruap, no. Although you have a volatile gases, you still able to use this condense absorber.
Liquid which is high in viscosity.
As long as it's liquid, you can use. As long as either it's a very viscous or not, doesn't matter. Vapor component, not really. Okay, as long as if one of the vapor you can make it as a liquid, then you can use this. Alright. Jawapannya adalah you make sure that you don't have any non-condensable gas. No non-condensable gas in your feed. Okay. So give me example. Okay, kita cakap, oh, Tong pun tadi cakap, wah, ya, siap tumbuk tangan lagi. Alright. Okay. Give me one example. What is non-condensable gas? Siapa cakap, oh, tadi panjang dia tulis, oh. Afika, give example, one non-condensable gas.
Hydrogen, ammonia.
Okay, Aiza, nanti aku minta satu je, kau pergi jawab banyak apa? Alright, CO2, CO, carbon monoxide, hydrogen, oxygen, ammonia. No, ammonia is not.
Argon gas.
Argon gas is not. Argon is what? Inert. Argon is inert. Methane, yes. Sulfur oxide, yes. Sulfur oxide, sulfur dioxide, hydrogen. What is the meaning of non-condensable gas? Okay, it's a gas. It's a gas that you cannot make it liquid. You cannot condense it at atmospheric condition. Betul, Jericho. Rico, betul. You cannot make it a liquid. Although at atmospheric condition, although at a very low low pressure condition, at a very extreme low condition, memang tak boleh dapat. Okay, I give you one example. How do you want to make nitrogen as a liquid? What is the condition that make nitrogen liquid ataupun hydrogen liquid? It's a very extreme low, right? Okay. Negative 200 or 300 degree Celsius at the minus temperature pressure, or at that atmospheric pressure, yes, at 1 atm, you may have a minus 300 degrees C, for example, very low temperature, which is impossible for you to supply that huge amount of cooling utility to satisfy that low temperature. Okay, sebab you have a condenser at the top. Kamu buat apa dry ice mineral? Kamu simpan di lihing dah. Nanti kau buatnya, kau campur untuk
mana ada
kau campur untuk dry ice dalam lihing. So you have a carbonated lihing. Oh, sedap tu. Belum ada orang bikin.
Kena bangun-bangun orang besok, doktor.
Carbonated lihing. Dapat orang dah tahu tu apa tu lihing.
Nantilah kalau curious tanya.
Okay, dry ice is basically you use very low temperature, you quench it. Okay, you guna gas yang paling rendah, dia punya boiling point to make that carbon dioxide as a liquid, as a solid. Okay, forget about it. That is apa situation yang mana kalau you skip the liquid phase, jadi solid terus ke gas, daripada gas terus ke liquid, terus ke solid. Dia tak lalu pun liquid phase. Okay. The reason why, because you have a condenser at the top. Since you're having condenser, so the function of condenser is to condense vapor gas, or vapor dalam form vapor gas lagi. You want to condense gas into a liquid. Jadi kalau you ada oxygen, you ada CO2 dalam tu, so how you want to condense it? How much cooling water that you need to supply? If you're using cooling water as your coolant, for example. So it is impossible. Sebab tu kalau you ada sahaja non-condensable gas dalam you punya feed, dalam your system, so jangan pakai yang ini. But you can use the previous one, yes. Not the previous one, the previous three. What happened if letak? Maksudnya, your separation is failed. Because CO2 is always recovered at the top. Okay? You always recover CO2 at the top. So, fail. Because in this case, kalau you pakai yang ini, So the product that you, this we call it distillate. The distillate here should be in the liquid form. Selagi you tak able to condense CO2, then your separation is failed. So therefore, in order for you to achieve that objective, then you need to supply a lot of cooling water, which basically is not practical. Economically, it's not practical. Okay? Nanti kita bincang macam mana you nak jadikan methane tu as a liquefied methane or liquefied natural gas. Itu lain. Okay? Itu ada proses dia yang tersendiri. So, kalau dalam tu you ada non-condensable gas, okay, now kita ada tengok flash, kita tengok absorber, kita tengok reboil absorber, kita tengok condensed absorber. So, kita ada berapa? Ada 4. So, among these 4, if you are having a non-condensable gas, mana separator yang you boleh pakai? Cakap 1, 2, 3, 4. Yang mana you boleh pakai? Kalau dalam itu ada non-condensable gas. If in your feed you have a non-condensable gas, so how many separator? 1, 2, 3, 4 tadi? How many of them you can use? 1, 2. Okay. Dua-dua boleh pakai. Lagi? Come on, manager. All of you akan jadi manager ni lepas ni. Plant manager. Jangan jadi plant operator. Operator is tak payahlah nak jadi operator, better you have jadi plant manager. Okay. When you have a CO2 in your feed, you boleh pakai flash. Yes, you can separate it using flash. If you have a CO2 in your feed stream, you can use absorber, tak ada masalah. Because flash and absorber are the same. You still can recover gas at the top. How about reboil absorber? Boleh pakai tak? Just type yes or no. Can you separate CO2 in your feed stream using reboil absorber? Come on guys, yes or no? Irene, itu jawapan ke soalan? Dia bagi jawapan tapi dia tanya balik. Okay. As long as sebab tak pasti tanya apalah jawapan dia Erin kalau tak pasti. Okay. You tak pasti yes, then jawapan dia no lah. Okay, dia as long as okay, kita tengok balik kepada reboil absorber. Okay. Mana dia? This is a reboil absorber. Is there any condition that halang vapor jadi liquid ke atas? Or can you recover vapor at the top of this reboil absorber? What do you think, guys? No. Okay, agree? Thank you. So easily you can recover the gas at the top. So 1, 2 dan 3 boleh pakai. If you have a non-condensable gas in your feed stream, you can use flash, you can use absorber, you can use also this reboil absorber. Tapi tak boleh condense absorber. Sebab you cannot condense it. Okay, clear? Bila masa you boleh pakai all this separator dan bila masa you tak boleh pakai all this separator. Okay, kita pergi kepada separator yang seterusnya. Oh, ini baru nombor 2, baru bagi bateri. Apa yang korang panggil batch? Semualah batch distillation column. Guys, batch distillation column tu tak ada feed dalam drawing dia, tak ada feed in dan tak ada stream out. One example of the batch distillation column adalah apa kita panggil dia, beer distillation. Beer column, they call it beer column. Okay, yang mana you all produce Li-Hing. Betul, Enrico? That beer column, we call it, that used to produce Li-Hing. Kau tanyalah si Enrico tu, dia selalu minum tu Li-Hing. So, beer column is an example of batch distillation column. Nak mengaku lagi si Enrico ni. Okay, that is example of batch distillation column. It's a beer column. Yang mana bawah tu is you have very big bottom. Ya, the column bawah tu is very big. Dan dia punya tower tu is smaller than the bottom and very depending on whatever kind of beer that you want to separate. Kadang-kadang kolom dia lagi boleh tinggi dan juga boleh rendah. Okay, so we go for the fifth column, yang mana the owner, which is still absorber still the owner, but in this case you have both. You have a reboiler at the bottom and also you have condenser at the top. So the question is, what do you call this? Apa you all punya jawapan? Semua sama je. Okay guys, based on whatever that we have discussed just now, okay, and by not looking at your answer and your friend answer, what do you think that the name of this separator? Kalau you ada dua-dua, you ada reboiler, you ada condenser, what do you call it? Hei korang ni, tolonglah yang start ni. Hei. Sufi pun sama juga mengarut. Mega absorber. Oh, kau macam Megatron je. Tentang dia apa atas bawah ada power lah. Korang ni, macam mana nak jadi manager ni? Okay dah, jangan pula keluar benda-benda mengarut-ngarut ni. Okay. Dual absorption. Banyaklah kau dual absorption. Okay guys, dah. The answer is distillation column. Bukan distillation column. Ingat kalau dia ada condenser, ada reboiler, itulah distillation column. Tak ada salah satu, is not distillation column. Tak ada dua-dua, bukan distillation column. Itulah korang. Memanglah patah balik. Korang awal menjawab. Padahal this is not the right answer. Okay? So, jangan ingat jawapan yang pertama tu betul. Dan korang ikut juga. Tong start jawab distillation column yang pertama tu semua ikut. Contohlah. Okay? Qayyum tiba-tiba jawab mega absorber, semua ikut. Okay? So, since banyaklah kau trending, viral dah tu kan, semua ikut. Alright, since you know that this is distillation column, where you have a reboiler at the bottom and you have condenser at the bottom, can you share with us bila masa kita boleh pakai ni, ataupun bila masa kita tak boleh pakai distillation column? At what condition that we cannot use distillation column? Can you guess? Boiling point dekat-dekat? Tak juga. We can still use distillation column if you have a close boiling point component. For example, korang kat mana? Korang kat Pagar. Korang tak pernah pergi melawat ke Sungai Udang ataupun Pengerang. There is the highest tower, the highest C3, C2, C3 rasanya. Oh, C3. C3 splitter in Asian. Okay. Ethanol and water is isotropic. We still can use distillation column, but not the high purity. Kita patah balik kepada C3 splitter tu. C3 splitter, C3 apa? C1 methane, C2 ethane, C3 propane. Okay, propane, propylene. The C3 splitter adalah to split between the propane and propylene. Okay, that is we have in Pengerang the highest in Southeast Asia. Okay, still distillation column. Okay, C3 and the propane and propylene, they are very close boiling point. So still we can recover using distillation column. Dah pastilah generico tapi lagi tinggi daripada kau lah. Nanti you all pergilah ajak apa you all punya kelas ni pergi melawat. Okay, ajak Dr. Aziz pergi melawat. Dr. Aziz lah, Dr. Haikal pergi melawat ke sana. Okay. Kita tengok balik kepada condensed absorber, apa dia punya restriction. So sama juga dengan distillation column. Selagi dia ada condenser, then you all tak boleh guna distillation column untuk separate non-condensable gas. Okay? Jangan sekali-kali pakai distillation column untuk separate methane. That's wrong. Jangan sekali pakai distillation column untuk separate gases. Oxygen, carbon dioxide, carbon monoxide. Okay? Practically, that's wrong. Because you need to do some condensation process there. Okay, you all dah buat plan design ke? Ataupun semester ni? Dah? Oh,
Last semester.
last semester ke? Nasib baik. Kalau saya check nanti, kalau saya check time tu, berdarah telinga korang mendengar saya membebel. Okay. Jangan sekali ingat, don't ever use distillation column if your stream containing non-condensable gas. Memang saya bantai korang terus. Fundamentally, that is wrong because you cannot condense that non-condensable gas. Macam mana you nak pakai distillation column? Okay, there is one condition yang you tak boleh pakai non-condensable gas, distillation column when you have a non-condensable gas in the feed. Okay, take note dah.
Jadi
all nak
bila
pergi-
kita jadi bila
okay.
kita boleh nak guna non-condensable gas tu?
Non-condensable
Untuk
gas,
separate
1, 2, 3 tadi tu. 1, 2, 3 tadi. Kolom 1, 2, 3.
Oh, okay.
Okay, sebab tak ada condenser. Usually kalau you ada non-condensable gas, better you flash out dulu. Very easy. Flash out saja. So guna flash. Sebab dia punya boiling point is very low. It always appear as a gas at the normal atmospheric condition. Okay? Alright. Boleh tanya soalan? Tapi sayang, you all dah lepas plan design. Kalau you tengok plan design, mungkin korang tertungging tengok balik apa you all design tu. Okay? Especially Tong. Dia mentam je. Suka hati dia. Okay. Syarat yang kedua. Yang pertama, disebabkan oleh you have a condenser. Since you have a condenser at the top, therefore you cannot have a non-condensable gas. Second is because you have a reboiler. So since you have a reboiler here at the bottom, sorry ya. Ya, bagi saya minum sekejap. Hampus. Si Jericho dia tahu, hampus. Dia kena minum lihing banyak baru hilang hampus. Okay, the second reason that because you have a reboiler at the bottom. Remember that this reboiler is supplied by the heat, by the steam. Okay, yang selalunya supply dalam tu adalah steam, either is a low pressure steam, medium pressure steam ataupun high pressure steam. So dalam kata lain, it's a steam sahaja. So since you know it's a steam, so this steam basically they have a limited heating utility, heating capacity yang you all boleh pakai to boil component at the certain degree of volatility sahaja. So disebabkan itu, there is some limitation. For example, you cannot have a higher hydrocarbon component dalam ni. For example, you cannot have kalau dalam you have feed stream to other wax, for example, ada bitumen, ada tar, which is impossible for you to vaporize it using steam. Then you cannot use distillation column. Then you also cannot use reboil absorber. Selalunya kalau you ada this higher ataupun high carbon change of hydrocarbon, higher change of hydrocarbon, selalunya dalam realitinya you akan pakai furnace to break it up into smaller change of hydrocarbon. Tapi kalau high change, you nak pakai steam, you nak pakai reboiler, it's impossible for you. Sebab tu distillation column ni dia punya condition is dia moderate. You tak boleh ada volatile component which is non-condensable. You cannot have a volatile component which is non-condensable, and you cannot also have heavier, which is difficult for you to make it vapor using steam. So they moderate. Okay, I can say between the C2, C3 until C20, 30 macam tu. 40 tu dah more kepada heavier lah tu. Okay, gas oil, wax oil, that is very heavier. So you tak boleh nak vaporize, sebab namanya reboiler kan, you reboil it back. You boil that component back, jadikan dia liquid. Jadikan dia vapor. Okay. Other than that, yes, you can use distillation column. Although it's a close boil component, close boiling point component, as well as isotropic. You can separate ethanol with water with a single column, yes, but you cannot achieve the highest purity possible. Paling tinggi pun 78-80% itu saja. Then you need to have another series of another one of the distillation column, the same one for you to purify it further. Okay. All right. Remember, this is a distillation column, and also remember that there is a condition that we can use all of this. So this is yang nombor berapa? Nombor 5. This is number 5, right? Separator number 5. Again, all of this is everybody. Kenapa pula ada binary? This is just a distillation column. All right. So the last column, the last separator, distillation column ni kita ada banyak. Kita ada extractive distillation column. Extractive distillation column which is basically kalau kita ada solvent dalam tu. That's what we call it, extractive distillation column. You add another solvent at the top, and the function of this solvent is basically to trap, to catch some of the component yang mana dia lagi feeble untuk dia nak bergabung and become heavier. then you can recover at the bottom. And the one which is not combined with the solvent, then it become vaporized. Since dia jadi less volatile, it become more volatile, then you can recover at the top and you condense it. As well as it's not a non-condensable gas. All right. So the last separator that we want to discuss today is distillation column. Sebabnya ada Daus, macam mana kalau kita ada reflux? Ada type separator yang spesifik. Reflux ni Daus, you need to remember that reflux is the function of the reflux is to bring back liquid to the column. Dalam distillation column, we have a one reflux at the top. Okay, yang masuk balik ke kolom tu kita panggil dia reflux. Yang keluar daripada kolom kita panggil dia distillate. So once, okay, why that you need to reflux it back? Because that is to maintain. First thing, once kalau you buat modeling, you kena faham benda ni, because some of the liquid need to be refluxed back because to maintain the mass balance, Okay. Once you're able to maintain the mass balance, then your model is stable. Maksudnya, sistem tu akan jadi stabil kalau mass balance dia stabil, meaning the volume within the stage is constant. Sebab tu dia kena ada liquid dalam setiap stage. Ini kalau belajar modeling ni baru best nak cerita. Okay, that's why you need to have a reflux. Okay, alright, Daus. Okay, now we look at this column, distillation column, but at the middle of it, dia ada satu side draw yang keluar. Selalunya side draw ni, ini yang paling simple lah, dia ada side draw macam tu saja. Usually you have another condenser, you have another reflux drum, and you have another reflux stream back. Dia sama macam kat atas tu. That's the practical way to have a side draw. Okay. If you have a single sahaja, a single side draw, so apa nama dia? What do you call this kind of separator? You can on your mic, you can type there at the chat. Ui, dah pukul 4 cerita benda ni saja. Control tak masuk lagi. Tak apa. As long as you all faham beza semua apa equipment ni. Okay, guys, what do you call this? Distillation column with a single side draw. Hai, Noha. Could try. Dia ada nama dia khas. Kalau saya beritahu, you all akan terkejut. Lagi. Good try. Lagi. What's the name? Tak ada 61 orang dalam ni. Extracting distillation column. Tong, no, you don't have a solvent here. Kalau you ada solvent, then baru you call it extractive distillation column. Single draw distillation column, not Irene. Direct, Sophie side draw, no, direct distillation column, direct. What do you mean by direct, Amir? Lagi, next. Siapa yang duduk pantai? Akmal, kau pun duduk pantai. Qayyum duduk pantai. Apa benda yang kau sokong Aziz? Sufi buat apa? Aziz is not selective distillation column, sorry. Azeotropic distillation column, not generical, you don't separate alcohol with water here. So ni generical, always talking about alcohol. Tahu lah kau minum lihing. Dapat rahsia kita saya tu lihing tu. Multi-component distillation column, no. Multi-component sama juga as a distillation column, kita tak sebut dia multi-component. Two-phase distillation column, no. Sorry Azhar. Could try binary distillation column. Doesn't matter, no, this is not binary. When you call it binary, it's still a distillation column with the two component. You want to separate. Tunggu sampai pukul 4 baru saya beritahu jawapan. Side draw distillation column, Akmal dah ada siapa jawab tadi tu. Side draw distillation column. Rasanya si Irene tadi, and then the first one siapa? Sufi yang jawab. Sufi lah jawab. Ya, Sufi yang jawab. Okay lah. Sufi yang antara yang pertama. Distillation column with side draw. Sorry, that's also wrong. Aziz Iskandar. Sufi jawab apa tadi? Side draw. Distillation column. Kira tu. Equilibrium separation. No, sorry. Complex distillation column. Complex. Okay, this is not complex. Kalau nak tengok complex distillation column, ada lagi complex. Continuous distillation column. Without side draw, kita panggil dia continuous juga. Fractional distillation. Not really. Fractional is just the way how you recover your product. Okay. Okay, let's talk about fractional distillation column. It is still distillation column. The only difference is when you want to separate the product, for example, you have a binary. You have a binary system in the feed. Okay, we are talking about fractional. Fractional. You have a binary. You have component A, you have component B at the feed. When you want to separate these two, fractionally, you still have a AB at the top and AB at the bottom. Ataupun dalam kata lain, kita panggil dia non-sharp splitting. Non-sharp splitting distillation column. Kalau dia sharp splitting distillation column, you recover 100%. You can have a pure component A at the top and pure component B at the bottom. Itu kita panggil sharp distillation column. Non-sharp, you ada dua-dua ke atas, dua-dua ke bawah. At a certain purity. Okay. Contoh non-sharp adalah isotropic distillation column, that example. Okay, that's we call it fractional. Packed column tak ada. Sufi belum bagi jawapan lagi lah. Pukul 4 baru saya beritahu jawapan. Ada seminit lagi. Okay, ada lagi yang rasa-rasa nak cuba? Okay, jawapan dia adalah this kind of column, when you have a side draw, a distillation column with a minimum of side draw, we call it refinery. Ya? Jika itu dia jawapan dia. Oh. Okay. Benda familiar kan? Macam tadi, familiar, you know distillation column apa dia. Tapi ada juga yang yelah kau Amin, dah agak lah. Okay. Ramai yang cakap, okay, nampak saja absorber, oh this is the distillation column. Okay. There is no maximum. Dalam refinery, at least kalau ada satu saja, we call it refinery. Okay. It can have more depending on how much product that you want to draw. For example, dalam oil refinery, crude oil refinery, you ada several side draw dalam tu. Okay. Depending on the, kita panggil dia, sorry. Kita panggil dia. Dia ada term dia yang khas. Not packing, splitting, something about dia punya pack, dia ada naphtha, okay, dia ada natural gas at the top, okay, ataupun liquefied natural gas dia ada ke atas. You have a liquefied first, selalunya kalau dalam crude oil refinery, di atas tu you recover LNG, liquefied natural gas. Okay, Noha nanti saya explain, saya cerita pasal refinery dulu. Okay, and then next after the LNG, you have LPG, liquid natural gas, and you have a liquid petroleum gas. Okay, itu side draw yang pertama. Yang dia recover adalah LPG, liquid. Dia beza dengan liquefied. Liquefied is different with the liquid. Ni liquid natural petroleum gas. Lepas tu baru you ada naphtha. Selepas LPG side draw, you akan ada nafta. Nafta ni pula terbagi kepada 3. Dia ada low nafta, dia ada mid nafta, dia ada high nafta, ataupun dia ada long apa benda lah. Dia ada lagi jenis nafta ni. And this nafta basically will be blend together with a certain chemical yang itulah guna sebagai kerosene, guna sebagai petrol daripada nafta. Kerosene tu jet fuel lah untuk kapal terbang, ataupun minyak gas yang orang guna untuk buat pelita tu. That is kerosene. Okay. Kero adalah daripada nafta. Petrol pun ataupun gasoline juga daripada nafta. Okay. That is after nafta split, nafta draw. Lepas tu baru ada diesel punya side draw. Lepas tu dia ada gas oil draw. So terpulang berapa banyak. Okay. Stripping, apa beza dengan stripping? Sama je fungsinya stripping ni. The only way that this stripping is general. Okay. Something that you can recover several component, that is we call it stripping. Tapi dia punya itu is not a common term. Dalam textbook kita tak panggil dia stripping. Okay. Mungkin dalam practical, dalam industri mungkin dipanggil benda macam-macam lah. It's okay. Tapi textbook punya term ataupun dalam buku teks we call it refinery. Sebab tu kita ada biomass refinery. Dia bukannya distillation column, biomass refinery tu is a process from where you can recover ataupun produce several chemical from biomass. Pernah dengar kan term biomass refinery? Dia bukannya distillation column, bukannya refinery yang kolom-kolom macam ni. No, it's a process to produce several chemical from biomass. Okay? Alright. So ingatlah, this is a distillation refinery. Tak kisahlah berapa banyak side draw pun tak apa. As long as minimum ada satu cukup. Alright. So what you need to do now is kita ada 5 jenis column ataupun separator, dan kelima-lima you all jawab dengan apa? Dengan tak berapa betul, sikit lagi. Sophie cakap sikit lagi nak bijak. Hampir, okay? Hampir nak bijak. Okay? So what I want you to do now is please comment it back at your response. Okay? Do the correction by yourself. Semua ingat kan? 5 kolom ni kan? Batuk lagi aku. Okay, so kita ada 1 jam lagi for us to go to the third part. Third part ni apa benda? Saya pun tak ingat ni. Third part ni. Ada third part ni. Okay, part 3. You nak rehat, you all nak minum-minum boleh, tak ada masalah. Jangan isap rokok je lah. Jangan isap vape, tapi mana tahu, bukan nampak pun kau all isap vape. Okay, part 3, apa benda ni? Okay, how to select suitable separator. Okay, there are several criteria that you need to consider in selecting suitable separator. First is the product objective. Separation objective usually is about product purity. When you're talking about separation objective, is to separate individual component at the desired purity. Okay, kita tengok tu. Tapi yang pertama you need to look at the purity. Once you know that okay, this kind of purity that I need to produce, I need to recover my product, then baru you able to select which type of daripada 5 tadi tu, which one that you want to choose. 5 plus extractive plus azeotrope, so you have 7. Product phase, look at the phase that you want to have your product is. Kita apa dalam fasa apa? Fasa gas, fasa liquid. And from that, baru you boleh select daripada 1 ke 7 tu, which one is suitable. Alright? So the first 2 is compulsory. It's very important. It's a must for you to look at. Then go to the energy consumption and the operation. So this is just additional. Okay, if you want to more detail on this, then you need to have a separate class on this. I have the separate class for this energy consumption selection and how you select a distillation separator based on energy consumption, also the separation operation. Sorry. Tetapi kalau dalam you punya plan design yang dah lepas tu, these two, the first 2 should be the one that you need to consider when you want to select your separator. Okay? Rasanya korang tak tengok pun. Okay? Especially the product phase tu. Okay, kita ada selection here, activity, a binary component fit. When you're talking about a binary component fit, basically we have 2 components there in one single fit. So it has a temperature difference of the boiling point about more than 50 degrees C. Okay, that is the main important point. Temperature, boiling point temperature different. Delta T, delta TP, delta TB. Okay, delta TB. More than 50%. What type of separator is suitable for this binary system? Okay, please justify your selection. Kenapa semua jawab batch ah? Korang ikut siapa? Tengok siapa yang first jawab batch ni. Semua mengikut je ni. Sophie kot. Sophie selalu ni kan. Dia selalu yang first. Tak mengaku kot. Tak. Influencer betul lah Sophie ni. Okay, nampaknya semua you all ni jawab batch. Okay. You know the difference between continuous and batch, right? Tahu ataupun tak? Tom? You know the difference between batch and continuous? Any single process, any whatever process. When you talk about batch, what does it mean?
Batch is just one input and then cut off the input there until the process is finished, and then they input the new process.
Okay, graphically, can you differentiate between the continuous and graphically, can you differentiate between continuous and batch process by looking at the graphic, by looking at the drawing? Boleh tak?
If the batch one, there will be a valve on the input, a control valve at the input there, and then there will be a feedback system.
Okay. No, that's not the answer. But thank you for the response. It's basically by graphically, if you want to know, or if you want to able to differentiate, if you want to differentiate between the batch and the continuous process, graphically by drawing. Contohnya batch stirred tank reactor. It's just a reactor. It's just a stirred tank reactor without any drawing of the stream in and stream out. Just a reactor. Just a vessel. Okay, a process without a feed stream and the outlet stream, we call it batch. Tak kisahlah dia reactor ke, separator ke. Dalam drawing dia tak ada, tak tunjuk pun lukisan tu. Stream tak ada, stream masuk, tak ada stream keluar. So that we call it batch process. Ataupun batch unit. Okay. Kalau ada salah satu, contoh kita ambil reaktor, kalau ada salah satu, sama ada feed in ke ataupun feed out, ada salah satu, kita panggil dia semi batch process. Tapi kalau ada dua-dua, dalam drawing tu ada stream masuk dan ada stream yang keluar, beberapa stream yang keluar, that we call it continuous. Okay. Regarding there is a control valve or there is a controller there, no. But we remember, Tom, remember that we only control a continuous process, not a batch process. Usually batch process is manually controlled. Sebab dia continuous, 24 hours, 24/7. Okay, 24 hours, 7 days, 24 hours per day, 7 days per week. Since it is continuous, non-stop, therefore we need to have a controller. Alright. So since that you need to be able to differentiate, adakah yang kita perlu pakai ini adalah continuous process ataupun batch process? And look at the statement there. Binary. When you're talking about binary, it's only have two component. Okay, two component. And there is another big hint over there, which is the delta TB is more than 50 degrees C. So R out kita dah bincang 1 sampai 5 separator plus the extractive number 6 and isotropic number 7. Do you think R out 1 and until 7 tu yang mana suitable for this kind of process, problem? Remember, it's just a binary. When you're talking about binary, you can separate it by using the simplest separator possible because it's just a binary. And the delta TB also very big, more than 50 degrees C. Can you use flash here? Azhar, aku sebut flash terus dia type flash. Laju je. Tapi dia memang cepat lah. Saya sebut flash dia baru nak ni. Okay. Okay, Azhar, why flash? That's why you need to justify. Sebab tak state nak dalam phase apa. Okay. Just one thing. Satu lagi is delta T itu besar sangat. Okay. You can use distillation column. It is possible for you to use distillation column. But remember that distillation column require another additional energy for reboiler and condenser. Okay. So kalau you punya selection based on purity saja, then distillation column is the right answer because you will have the highest purity possible using distillation column. But if this statement is not talking about purity, it's just talking about delta TB. Remember? Kalau dia cakap, okay, the top product should be at the 99.5% purity, at the bottom should be at 99.6% purity. That is basically there is a specification of your product purity. Therefore, only the distillation column able to do that, able to achieve that. Sebab you have a mechanism, you have a reboiler, you have a condenser, which you can manipulate the flow rate of the cooling water at the top and also the steam flow rate at the bottom in order for you to achieve that desired purity. Tetapi if the purity is not mentioned here, then flash is enough. Okay. Another justification that you can give here, since flash is the less energy required separator. Tak ada pun, tak banyak pun, memang tak ada energy pun sebab it's just a flash. You tak perlu pun ada reboiler, you tak perlu pun ada condenser. Okay. Since the boiling point difference is quite big there, then flash is possible. Okay. Tetapi kalau ada statement cakap that both binary point are close boiling point component, then if that's the case, if both binary point, there is an additional statement there, both binary component are close boil component, then what separator that you will use? Any idea?
Isotropic.
Close boil. Close boil usually with extractive. Bukan isotrop. Okay. When we are talking about close boil, the answer is extractive distillation column. Sebab dia punya molecular weight are similar. Okay. Yang different dia adalah dia punya satu ada double bond, satu single bond. Itu saja bezanya. So that's why we call it cross boil. Kalau we call it isotropic binary, then baru kita boleh pakai isotropic distillation column. Okay. Close boil pun kita boleh pakai ordinary distillation column. Tak ada masalah, you can achieve the purity. Cuma disadvantage-nya, if you use distillation column to separate close boil distillation close boil component, you may end up with the huge number of stages. Sebab tu apa yang berlaku di C3 stripper di Sungai Udang Petronas kat Melaka tu 170 meter tingginya. Okay. So far dia di highest lah sebelum pengerang wujud. Now since pengerang dah ada, so pengerang take over. The same thing also for the C3 splitter. Saya rasanya pengerang almost more than 200 stages kat situ. So kalau kita ada number of stage, 200 stage, berapa meter? 200 stage. Berapa tinggi dia? Any idea? Selalunya kita cerita design of the column ni, kita then how many stage? Okay, I have a 200 stage. So 200 stage tu berapa tinggi? Berapa meter tinggi dia? Ini idea, you all ni dah buat plan design kan? Tak payahlah Fika. Dia selalu tu tak tahu jawapan tu. Satu stage bersamaan dengan 0.5 meter. Half meter, one stage. That is the standard. So if you have 200 stages, so you have 100 meter. Bayangkan 100 meter tu, yang all lari 100 meter tu, you dirikan dia tinggi mana? Tegakkan benda tu. It's very, very high. Okay, 100 meter. That's why if you have more than 200 stages, basically It's not feasible. Design tu is not feasible. 100 meter height. Lepas tu dia punya diameter pula 1 meter diameter. Oh, batang pinang. Bukan lagi batang kelapa, batang pinang. That is basically your column. It's like a batang pinang. Very high dan kurus. So there is a limit for the feasible design of the distillation column. There should be a limit. Okay? Memang tak boleh lebih pun a certain number sepatutnya lah. And selalunya kalau nak buat juga, for example, if you want to design, okay, nak juga design 200 stages, then you need to split. You need to split the column into two. 100 meter height is very, very unsafe. Senang saja boleh tumbang. Kalau you berdiri, kalau you all dirikan pun memang tak boleh stabil, memang goyang-goyang. Macam pokok pinang. Okay. Angin sikit je pun dah goyang-goyang. Okay. Tapi tak apa, you all dah lepas plan design kan, confirm mesti ada dia punya number of stage 100 lebih. Tak percaya pergi check balik nanti. Alright. Every one single stage is equivalent to 0.5 meter. Ada soalan lagi tak? Mari kita tengok. Okay, yang ini. Okay, ini quite easy. Rasanya kita dah banyak bincang tadi. Your feed components, you have a CO2 and you have propane and pentane. So what type of separator suitable for this? Please justify your answer. Apa you all jawab? Continuous multi-component distillation column. Semua ikut Sophie ni kan. The influential, nama lah influential separator, semua sama. Okay. Since kita dah bincang benda ni, then you have these three component. Kita tengok balik, you have these three component dalam you punya feed. Can you give me what kind of separator that you want to select daripada 1 sampai 7? Contoh, walaupun extractive dengan azeotropic kita tak bincang in much detail, at least you know the use of it. Based on this, of course, you all pun tak setuju dengan whatever answer yang you all dah bagi kan? What do you think? Which separator that you will use here? Reboil absorber. Okay, Azhar, yes, you can use reboil absorber. Lagi? Other than reboil absorber? Any reason? What is your reason, Azhar? You use reboil absorber? Cakap jelas. Kadang orang malu, suara emas dia malu nak berkongsi suara dia. Okay. Any choice of separator? Sebab ada non-condensable gas. Yeah, that is the right answer. That's why you use reboil absorber. Since you have a CO2 there. Oh, ya ke? Cakap dah balik college? Dah balik college belum? Dah balik cepat-cepat pergi Pago. Pago line slow. Buat apa kalau Pago pun slow? Buat apa nak balik kalau macam tu? Dah. Azhar, Pika cakap tak payah balik. Duduk rumah je. Okay. Since you have a CO2, the non-condensable gas in your feed, therefore, rather than reboil absorber, what kind of separator that you can use here? I don't think that reboil absorber is the right answer, but you can use it, but not the right one. Okay, Noha, distillation column. Distillation column memang tak boleh. Sorry, you cannot use distillation column for this case. Reason dia sebab you have non-condensable gas. You cannot condense it. So kalau itu jawapan you, memang saya bagi kosong terus. Kalau ini yang you jawab dalam you punya distillation you punya plant design, memang kau lah kena. Flash absorb sebab ada non-conductible gas dan dia less energy cost. Okay, either you want to use flash ataupun absorber, yes, both much better than reboil absorber. Although reboil absorber you can use to separate CO2, but what is the purpose for you to reboil the liquid? Since CO2 never be a liquid. Okay, CO2 never be in a liquid. Therefore, reboil absorber is not the right answer. Although you can separate CO2 from the liquid, yes, tapi it's not the right answer because the reboiler tu rugi saja you install reboiler sedangkan the purpose is not meet the objective. Okay? The purpose for you to use reboiler is not meeting your objective. Not efficient, yeah. Not energy efficient, Fika. That is the right term, not energy efficient. Tu je jawapan kau.
Flash column.
Flash, yes. You can use flash. You can also use absorber. Depending on either you able to recover. Okay, the first choice that you can use is flash. If a single stage of flash able to recover all the CO2 in your feed stream, that should be the one. Okay. Kalau a single stage of flash cannot recover CO2 totally, then you use absorber. Sebab absorber ni dia ada multi-stage. Tapi disadvantage dia, cost dia tinggi lah sebab you ada multi-stage rather than flash sahaja. Sebab tu depending on the purity juga. You need to consider the purity. Tapi kalau flash boleh recover 100% of your CO2, just use flash. Okay?
Doktor, kalau
Ya,
macam nak ikut dia punya purity, better guna absorber lah macam tu.
Not really. Not really absorber. Sebab tu you kena consider first. There are several choice. In the engineering problem, kita akan ada, okay, you need to come up with the several solution. Bukan satu solution sahaja. And from that baru you akan test one by one. For example, in this case, since you have a CO2 at your feed stream, therefore hanya 3 sahaja separator yang suitable. Yang you all boleh pakai. Yang pertama adalah flash, yang kedua adalah absorber, dan yang ketiga adalah reboil absorber. Ketiga-tiga ni boleh guna sebab you have a non-condensable gas at the feed. Condensed absorber you tak boleh pakai. Distillation column apa lagi? Sebab you ada CO2. That is the problem. CO2 ni kena buang dulu. So ketiga-tiga ni boleh pakai. Okay. Lepas tu you tengok balik. Reboil absorber you reject. Kenapa you reject absorber? Sebab there is no purpose for you to reboil the liquid. The purpose of you to reboil the liquid is to make sure that your desired product at the top tu, kalau dia masih lagi dalam fasa liquid, therefore you need to reboil it. You need to make it as a vapor. Sebab tu perlunya reboiler. Dan the vapor tu kita masuk balik dalam column and kita recover it at the top. That is the purpose of reboiler. Tetapi dalam case ini CO2 takkan dalam bentuk fasa liquid. Never. It will never be at the liquid phase. Then reboil absorber can be rejected. Sebab there is no purpose for you to reboil. Okay, reboiler tu tak guna pun. Alright. So tinggal kepada dua alternatif sekarang ni, either flash ataupun absorber. So you start with the flash. Sebab tu once you get this kind of alternative, contoh tinggal dua alternatif saja, then barulah you guna simulator to prove yang mana lagi baik, flash or absorber. Okay, first you start flash dulu. Okay, you simulate. Okay, you can recover you can recover CO2. Totally. Okay, totally you can recover CO2. Then that is the choice. Sebabnya flash lagi murah banding dengan absorber. Sebab absorber you have a multi-stage. So the capex, the capital expenditure to build flash is much lower than absorber. Tapi kalau flash tak boleh, once you do the simulation, flash only able to recover 80% of the CO2, then baru you pakai absorber. So flash is not satisfying the first criteria, which is the product purity. Okay, nah?
Okay, doktor.
Sebab tu ekonomi kena tengok energy. Kan dua-dua tu ada kan, tapi benda tu berada ke the second option. The first option you look at the purity first. And then baru you tengok kepada energy, baru you tengok kepada operation. Okay? So the answer can be flash or absorber depending on the verification by using simulator. Sayang, kalau you all, saya boleh tengok you all punya plan design lagi bagus ni. Alright, so we look at this question. Look at this statement here. Tadi you dah recover CO2 kan? Tadi kita ada 3 komponen CO2, propane and pentane. Now we already recover CO2. Now we only have a propane and pentane at our feed stream. So both top and bottom products are in liquid phase. Liquid phase. Both are in the liquid phase. So what do you think? The most suitable separator that you can use here? Tengok apa panggil. Allah Akbar, reactor pula, reactive distillation. Okay.
Boleh pakai distillation column?
Jangan tanya, saya tak nak awak tanya soalan, saya nak awak bagi jawapan.
Itu jawapan saya.
So jawapan dia apa Noha?
Distillation column.
Distillation column, okay. Yang lain? Okay, kenapa you nak pakai distillation column Noha?
Sebab dia tak ada non-condensable gas.
Okay, lagi?
Lepas tu
Tengok ayat tu, tengok ayat. Tengok statement dalam tu dia nak apa? That is how you select. Apa yang menyebabkan
Ya, saya kat sini.
Ada apa-apa ni? Kenapa you pilih selain daripada non-condensable gas? Sebab memang tak ada pun non-condensable gas.
Sebab kalau pakai distillation column, dia lebih kepada purity.
Dalam tu tak ada carbon purity.
Tapi kalau macam dia mention pasal liquid phase, sebab dua-dua tu kan dalam liquid.
Okay, so kalau dua-dua top and bottom liquid phase, adakah distillation column sesuai?
I think yes.
Kalau think tu memang tak lah tu. Kan?
Yang lain jawab.
Azhar.
Kalau guna condense absorber boleh ke?
Condense absorber. Propane dengan pentane. Propane C berapa?
C3.
Pentane?
C5.
Okay. Yes, you can use condense absorber because it makes sure that you condense propane at the top and leave it pentane as a liquid at the bottom. Yes, you can use it. But the question, can you, oh, they're not talking about purity here, but it's okay, just phase. Okay. So you can use either condensed absorber or distillation column. Ingat, when you're talking about purity, now you're just talking about condition. We're talking just about talking about phase. Okay. Kalau we are talking about phase pula phase, liquid both should be liquid, then both of these separator are capable. Dia boleh buat, boleh achieve. But when we are talking about purity, purity at the top and purity at the bottom, dalam ni tak cerita lah kan. Okay, let's say there is another condition, another criteria, is the purity at the top and bottom should be maintained at a certain value. Yang mana rasanya you all boleh pakai?
Distillation column.
Yeah. You should use distillation column because you need to maintain or able to control the top and bottom purity. Okay. Okay, let's analyze this another situation. Kalau kita nak maintain top purity saja, we don't care about the bottom purity. We just want the bottom in the liquid phase, but the propane at the top should be at the liquid phase, but at the certain quality.
Is it reflux ratio?
Mana ada reflux? Apa benda tu? Apa nama separator dia?
Kalau
Azhar, mana boleh guna refinery mengarut dengan ni Azhar? Itu kalau kau ada banyak produk bolehlah pakai refinery. Sekarang ni yang kita nak maintain tu as a liquid at the bottom, kita tak kisah pun purity dia berapa. Kita tak nak control pun purity dia. Yang kita nak control saja adalah purity of pentane, propane at the top. And that should be in the liquid form. Ya, Noha?
Boleh pakai condense sebab dekat condense tu dia ada condenser. So kita boleh maintain dia punya purity propane sahaja.
Ya, sebab we know that pentane should be in the liquid. But uncontrolled, kita tak control dia. Tak nak jaga dia punya quality. Yes, you can use condensed absorber. Nampak tak? Bukan semuanya sama. Semua ni berbeza. Dan sedikit beza tu very huge in operation. Impact dia banyak, very big pada operation of your plant. Tom, macam gatal kepala kau. Okay. Tadi yang mula-mula kita tak boleh pakai distillation column sebab ada CO2. Okay. So the selection is basically, again, you look at the several conditions, several criteria. Tapi the most common adalah the criteria is purity. When you're talking about purity, if you maintain the purity, maksudnya you kena ada something that able to adjust, yang you can adjust to in order for you to achieve that desired purity. Kalau top and bottom, so the best is distillation column sebab you can adjust the reboiler. Reboiler you use to adjust the steam in order for you to maintain the quality at the bottom, and you maintain you manipulate cooling water at the condenser such that you're able to maintain the purity at the top. Okay, tetapi both of them, these two, walaupun dia boleh kita guna sebagai untuk kita maintain the purity, tetapi dari segi ekonomi, it will require a lot of energy. In terms of operation, the operating expenditure, you require a lot of energy because you use steam and cooling water to maintain the purity. Okay? That's what you call the simplest separator is flash. Flash tak guna apa-apa energy pun. Dan dia cuma single stage. That's the simplest, but the simplest shouldn't be the best. Cannot be the best, but sometimes yes. Okay. So that's why in this case justification is very important. Kenapa you pilih benda ni? Kenapa you pakai ni? Kenapa you nak guna equipment ni? Justify, give me the reason why. Bukan saja you main letak-letak saja dalam you punya presentation. I do believe that all of you in your simulation, nampaknya you all pun tak buat simulation kan? Buat tak? Buat. But I do believe that you all main letak-letak saja. Okay? Agree right? Sebaiklah saya tak check you all punya presentation project tu. Okay. Because this is not only for you, even those who already experienced working in industry pun sama juga, they still cannot differentiate between all these separator. Masih lagi semua macam you all lah cakap semua tu adalah distillation column. Okay. So, but I don't want you to be like them. At least you able to differentiate between apa bezanya distillation column tu in term of reboiler dan condenser pun dah cukup dah. Distillation column kena ada dua-dua ni. Contoh kalau you argue dengan you punya senior dalam bila you kerja nanti. Ataupun you next semester you want to go to practical. Okay? Dia cakap ini column. Then you argue. You tahu tak? Distillation column ni, ini column ni kalau kita nak panggil dia distillation column, dia kena ada condenser at the top and reboiler at the bottom. Kalau tak ada tu, it's not distillation column. At least you can able to describe, explain something like that pun dah cukup lah. You don't have these two, itu adalah separator biasa. It's not distillation column. Oh, kau tu Pika tak boleh panjang lagi ke? Sama saja bilangan kau tu. Dari tadi sama je. Memang kau kira ke benda tu? Okay, next time kau kira letak satu dulu, letak dua, letak tiga. Ada lagi tak? Oh, ada lagi. Ini dah. Ataupun belum ni ke? Okay, belum. Alright. Ini another situation. I think this should be the last one. Okay. Pika masih ada lagi, Pika. You boleh masih lagi type kau tu panjang-panjang. Tengok apa jawapan. Alright. Jawapan pun semua salah. Okay, what do you think? Since you have discussed this one more than 3 hours, or not 3 hours, more than 2 hours, almost 3 hours, what do you think of this? You have the same component macam tadi. Yang tadi kita nak dua-dua tu sebagai liquid, tapi in this case we want top product as a gas phase. Okay, kita nak top product to gas, bottom ataupun pentane as a liquid at the bottom, propane as a gas at the top. Okay. Give me the answer. What kind of separator that you will use based on this situation?
Distillation column.
Siapa yang jawab?
Pakai distillation column.
Syed Iskandar. Why?
Okay, propane dengan pentane dia apa under carbon ni tu kan. Pentane dia high dia punya boiling point lagi tinggi, so dia akan distill ke bawah, iaitu dalam reboiler. Propane dia punya tu boiling point dia rendah berbanding dengan pentane, so bila kita heat up, so dia akan naik atas. So dan dia bila naik dalam condenser, so kita akan dapat produk propane dengan pentane.
Propane tu selepas dia lalu condenser dia jadi apa? Apa fasa dia lepas lalu condenser?
Liquid balik aku.
Liquid. Tengok condition apa yang kita nak.
Oh,
Dia
sorry.
baca balik tu.
Sorry. Tak.
So boleh pakai distillation column tak?
Tak.
Okay, thank you Zik.
Sorry, tak baca soalan tu.
Tak apa, biasalah semangat. Tak apa. Kanzul Fikri, GG tu apa? Good game, good game. Kau ingat aku apa? Squid Game ke apa? So, your answer is what? Report dalam apa? Gamer. Ya. Sebab you nak at the top tu sebagai guest. So the answer is reboil absorber. Ada lagi? Boleh tak guna absorber saja? Boleh tak you pakai flash?
Tak boleh.
Kenapa Noha tak boleh? Saya cakap boleh. Saya cakap boleh.
Sebab ni pendapat saya, sebab saya rasa sebab kalau dia nak separate, bila propane dengan pentane tu dekat feed, so bila dia separate dia masuk dalam kolom tu,
Okay.
Propane still maintain dalam liquid, bukan gas phase.
Betul ke? Are you sure? You tak boleh jadikan propane tu sebagai liquid, sebagai vapor. Then you change the feed condition. Make sure the propane in the gas phase before coming into the flash drum. Sebab tu saya cakap flash boleh pakai. You can recover propane as a gas using flash and propane as a liquid. Because flash, kalau you tengok balik, kalau you pakai flash, always you get gas at the top and liquid at the bottom. Sama juga dengan absorber. The only question that you can argue is about purity. Okay, that's the only thing that you can argue. Tapi if the question asks, can you separate these two using flash? The answer is yes. Can you separate these two using absorber? The answer is also yes. Can you separate these two using reboil absorber? The answer is also yes, because these three separators will recover propane as a gas phase at the top. Okay? So ada 3 sekarang ni. So you ada 3, you ada flash, you ada absorber, then you ada reboil absorber. Then barulah you pergi tengok kepada another criteria. If you're talking about energy consumption ataupun energy efficiency, then you boleh tolak awal-awal reboil absorber sebab dia ada utility. When you're talking about purity, then flash can be you may argue on the use of flash. Are you able to obtain propane purely at the top using flash? My answer is not sure unless you prove using simulation. Okay? But the question asked is, what is, if the question asks, can you able to use flash to separate? Memang jawapan dia boleh. Tapi how pure is it? Depend on how you manipulate the feed condition. Sama juga dengan absorber. It depend on how many stages that you want to design your absorber, such that you're able to obtain the high purity of propane as a gas in the gas phase at the top. Okay. So when you solve, as I mentioned before, when you want to solve engineering problem, especially engineering design problem, you always analyze, okay, the option. Okay. Contoh kita ada 7 lah. 7 separator, then kita zoom in out. Kita remove several separator yang able to produce liquid at the top sebab kita nak gas at the top. So kita buanglah distillation column, kita buanglah condense absorber, kita buanglah whatever that's related with the distillation column. So tinggal 3. So these 3 baru kita further analyze with another criteria, another constraint. Dan barulah kita boleh pilih the best one. Okay? Setuju semua? Okay?
Setuju.
Kita dah 4 almost 5 ni. Okay. Alright, so tak habis juga, tak masuk kontrol lagi. Tak apalah, kontrol kita tengok next week lah. Ada lagi soalan? Tak ada. Okay. So, closure. Banyak benda. Banyak benda kita belajar kan? Belum masuk konten lagi ni. Kita tak masuk konten lagi. Kita tak masuk lagi pun apa commissioning. Kita tak masuk lagi. Baru kita tengok ni basic ni. Basic design baru. Design and operation. Belum kita masuk lagi basic control lagi. Remember when we are talking about operation, ini kita tengok next week lah. Ataupun kalau kita ada masa, kita boleh buat kelas ganti malam ke, subuh ke. Rehat ke, you all ada kelas tak? Sebab 2 section ni kan yang payah sikit ni. Petang ke, pagi, Ahad ke. Kalau ada free, siapa ketua kelas lah? Mengarut engkau Kanzo. Okay, engkau since kau menjawab, so aku lantik engkau sebagai ketua kelas untuk ketua dia ni. Ya, betul Azhar. Kita lantik dia sebagai ketua kelas. So make sure that you find a time suitable for both section that at least kita boleh bersama, tak kisahlah. Minimum is sejam. Sejam. Kalau boleh 2 jam cukup. Tak semestinya 3 jam lah. It's very difficult to find the 3 hours where apa benda lah Fika ni kau ni. Ini mesti budak WeChat ni kan. Okay. Sejam, 2 jam, tak kisah. 3 jam, no. Very difficult to find the 3 hours for those both sessions. Ada 1 jam, okay cancel, then you inform me bila, then we start do our kita jadikan dia sebagai kelas kita nanti. Maksudnya kita akan jumpa hari Rabu, kita jumpa hari Khamis, dan juga kita akan jumpa hari Ahad kalau ada free. Okay. Thank you, Hansel. Oh, ketua yang menurut perintah. Terima kasih. Okay, closure. So, ada 5 minit lagi sebelum kita close. Ya, betul Syahir. Ketua kita kena selalu puji ketua supaya dia buat kerja. Ke mana dia? Okay, operation. Operation is very important. Sorry. Tangan ni bergerak pula. When we are talking about operation, then kita tak boleh lari dengan proses control. When we are talking about process control, then kita tak boleh lari dengan proses dynamic. Ini yang kita akan tengok next week. Sebab nama subjek ni adalah plant operation. Okay, plant operation and management. When you talk about operation, you tak boleh lari daripada control. When you talk about control, you tak boleh lari daripada dynamic. When you talk about dynamic, you tak boleh lari daripada design. So semua ni berkait. When you talk about design, then baru you tak boleh lari daripada fundamental of unit operation, fundamental of reactor, fundamental of separator, fundamental of the heat integration ataupun heat exchange. All those require some fundamental. And this fundamental basically help you in analyzing certain operation condition, especially if you have a problem in operation. Okay, kalau teruk, then it will help you in troubleshoot the problem. That is the most important. But be in mind that if you design your reactor, if you design your separator, based on, ataupun if you design the heat exchanger network based on the fundamental, their own fundamental, believe me, your operation will become smooth. Your plant operation akan jadi smooth. Once your plant smooth, then control tak banyak masalah. Sebab proses smooth je, tak ada disturbance. Bila control jadi senang, tak ada masalah, you tak perlu buat retuning, you tak perlu buat adjustment, then plant you akan make profit, tak terkait non-stop make profit. Itu yang kita nak. Okay. Tapi based on kita punya revisited activity tadi tu, I do believe that most of you design benda, you punya reactor, you design you punya separator berterabur. Okay. Main tangkap je, tangkap muat je. Tak tahu pembeza antara satu dengan lain. That is very important. Okay, tak kenal maka you tak cinta. Tak cinta you tak tahu. Tak tahu kena kenal. Okay, you want to become a manager, you need to understand, you need to kenal semua, bukan saja orang yang ada dalam you punya plant. It's not only personal in your plant, but also the equipment. Okay, how the behavior of the equipment, how the equipment behave. Pagi macam mana perangai dia, tengah hari macam mana perangai dia, petang macam mana perangai dia. Bukan saja orang ada perangai, equipment tu ada perangai. Okay, bila time hujan, what happen? Tengah hari tiba-tiba hujan, then the pressure will drop. Once pressure drop, then temperature pun akan follow. Then kelang kabut lah you all nak maintain nanti. Believe me. Okay, so that's basically if you have a very good fundamental of your reactor, if you have very good fundamental of your separator, then you able, believe me, you will able to bring that condition back to the set point easily. Kita akan tengok benda ni nanti. Okay, that's all for today. Thank you for your cooperation, participation. Most of you basically telah masuk pun dah, basically you dah cover pun chapter introduction ni dah habis was, tapi kita tak discuss lagi. Saya pun tak boleh percaya you punya jawapan tu. Macam apa yang you all cakap tadi lah, siapa Allah. Siapa tadi influencer tu nama dia?
Sufi Huzaimi.
Sufi, aku lupa nama kau influencer ni. Korang jangan ikut saja cakap dia tu, apa yang dia jawab tu. Dia tu influencer saja. Okay, Tong pun sama juga, dia main tam dia jawab, kadang-kadang orang follow dia. Okay. So based on our discussion tadi, make sure that you do the correction, comment back, especially on the different yang apa, part 2 and part 3. Part 3 rasanya banyak yang salah, almost wrong. Part 2 pun sama juga. Okay, it's good that you do wrong now rather than later. Okay, tapi sebaiknya you all tahu benda ni sebelum you all buat plant design lagi baik. Tapi plant design dah lepas, itulah rugilah. Okay, ada apa nak tanya Sufi? Oh Sufi, senyap kau? Tiada? Bagus. Alright, so if there's not a question, so thank you very much. So hopefully kita tak jumpa besok, kita jumpa. Ketua kelas, kalau Ahad ni free, then kita boleh set time, then kita boleh have some makeup class hari Ahad ni. So depend kepada ketua kelas, ketua kampung. Ketua kampung dapat cari masa, then we have, because a lot of things that we need to discuss, especially on this control. Sebab baru kita cover 2 topik untuk design pun dah lebih, tak cukup 3 jam. Okay, tak apa, kita pelan-pelan. Yang penting semua faham. Okay, alright, kalau tak ada, thank you very much. That's all for today. Thank you, and I need to stop this recording.
Thank you, Doktor.
Terima kasih, Doktor.
Thank you, Doktor.
Thank you, Doktor.
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 Thank you, Doktor.